Hello, all you lovely people, and welcome back to What's Up, your monthly guide to the sky. Currently, we are in the month of March, and that means the March equinox is going to be happening. I will talk more about this later, but for right now, I have about 5 events that I want to discuss. The first event that I would like to talk about is the conjunction of the Moon and Saturn, which will take place on Tuesday, March 9th. The Moon and Saturn will share the same right ascension, with the Moon passing to the south of Saturn. The Moon will be about 26 days old. Because of the Moon being about 26 days old, it will be a waning crescent that will be about 12% full. So it'll look about like what the picture looks like. At around the same time, the two objects will also make a close approach, technically called an appulse. From Moorhead, the pair will be difficult to observe as they will appear no higher than 8 degrees above the horizon. They will be visible in the dawn sky, rising at 5:24 a.m. Central Standard Time and reaching an altitude of 8 degrees above the southeastern horizon before fading from view as dawn breaks around 6:32 a.m. Both the Moon and Saturn will be in the constellation Capricornus during this event. The pair will be too widely separated to fit within the field of view of a telescope, but will be visible to the naked eye or through a pair of binoculars. The second event that I would like to talk about is Gamma Norman meteor shower. The Gamma Norman meteor shower will be active from February 25th to March 28th, producing its peak rate of meteors around March 14th. Over this period, there will be a chance of seeing Gamma Norman meteors from anywhere where the shower's radiant point, which is in the constellation Norma, is above the horizon. Unfortunately, however, I will not be able to see it from Moorhead at any time since its radiant point never rises above the horizon. So hopefully you guys can let me know how it goes, because apparently I just have bad luck for being able to view meteor showers. Anyway, so as previously stated in my earlier videos, meteor showers arise when the Earth passes through streams of debris left behind in the wake of comets and asteroids. Over time, the pieces of grit-like debris in these streams distribute themselves along the length of the parent object's orbit around the solar system. To see the most meteors, the best place to look is not directly at the radiant itself, but at any dark patch of the sky which is around 30 to 40 degrees away from it. It is at around this distance from the radiant that the most meteors will be seen. By determining the position of this radiant point in the sky, it is possible to work out the orbit of the stream giving rise to any particular meteor shower. It is sometimes even possible to identify the particular body responsible for creating the debris stream, if there is a known comet or asteroid with a very similar orbit. The Gamma Norman meteor shower radiates from the Norma constellation, which is a small constellation that is seen in the southern hemisphere. The radiant point is near the star known as Gamma Normae, which is the brightest star in this constellation. The zenith hourly rate, or how many meteors you expect to see during this hour, is about 4. The third event that I would like to talk about is the March equinox, which will be happening on Saturday, March 20th. The March equinox marks the first day of spring for anybody living in the northern hemisphere, and the first day of autumn for anybody living in the southern hemisphere. On the day of the equinox, everywhere on Earth has almost exactly 12 hours of day and 12 hours of night, as the sun's annual journey through the constellations of the zodiac carries it across the celestial equator. The word equinox is derived from the Latin words equus, which means equal, and nox, which means night. The direction of the Earth's spin axis remains fixed in space as it circles around the sun, while the Earth's sight line to the sun moves through the constellations of the zodiac. As a result, sometimes the Earth's north pole is tilted towards the sun in June, and sometimes it is tilted away from it, which is in December. This gives rise to the Earth's seasons. At the intermediate points between the solstices, the sun lies directly over the Earth's equator on around the 21st of March and the 23rd of September. In March, the sun is traveling northwards across the equator, and in September it is traveling southwards. At the March equinox, the sun has a right ascension of almost exactly 0. This is because the 0 point of right ascension is defined by the position of the center of the sun at the moment of the equinox. In practice, the sun's right ascension is not exactly zero because the direction of the Earth's spin axis in space is not completely constant. The Earth rotates like a gyroscope, causing the location of the equinoxes to creep across the sky at a rate of around 50 arcseconds each year. The fourth event that I would like to talk about is when Venus is at superior solar conjunction. This will take place on Friday, March 26th. Venus will pass very close to the Sun in the sky as its orbit carries it around the far side of the solar system from the Earth. This occurs once in every synodic cycle of the planet, which is 584 Earth days, and marks the end of Venus's apparition in the morning sky and its transition to become an evening object over the next few weeks. At closest approach, Venus will appear at a separation of only about 1 degree from the Sun, making it totally unobservable for several weeks while it is lost in the Sun's glare. Venus will also pass apogee, the time when it's most distant from the Earth, at around the same time, since it will lie exactly opposite to the Earth in the solar system. So this last event kind of coincides with the previous one, but this event is Venus at its greatest brightness, and this will take place on Sunday, March 28th. Venus will reach its greatest brightness in its 2021 evening apparition during this time. Venus's orbit lies closer to the Sun than the Earth's, meaning that it always appears close to the Sun and is lost in the Sun's glare much of the time. It is observable for a few months each time it reaches greatest separation from the Sun, which is its greatest elongation. These apparitions repeat roughly once every 1.6 years. On these occasions, Venus is so bright and conspicuous that it becomes the third brightest object in the sky right after the Sun and the Moon. It is often called the morning star or the evening star. Venus's brightness depends on 2 factors: its closeness to the Earth and its phase. Its phase varies depending on its position relative to the Earth. When it passes between the Earth and the Sun, for example, the side that is turned towards the Earth is entirely unilluminated, which is like a new moon. Conversely, when it lies opposite to the Earth in its position, passing almost behind the Sun, it appears fully illuminated like a full moon. However, at this time it is also at its most distant from the Earth, so it is actually fainter than at other times. Venus reaches its brightest when it is still a crescent, with less than half of its disk illuminated. This is because it is much closer to the Earth during its crescent phases than at other times. As a result, during evening apparitions, Venus reaches a maximum brightness a few days after it's at its greatest elongation from the Sun, which was the previous event that I was telling you guys about. Conversely, during morning apparitions, Venus reaches maximum brightness a few days before it is at greatest separation from the Sun. Thank you guys so much for watching. If you have any questions or other events that you would like to know more about, please leave them in the comments and I will try to get to them as soon as I can. And also make sure to follow the MSUM Planetarium and all of our social medias to stay up to date with other events that we have going on here and other information that we may have for you. I really hope you guys enjoyed learning. I know I absolutely love getting to know about what's happening in space and everything that is going on around us that we don't even know is happening. But until next time, I hope you all enjoyed getting to know what's up.